All right, everybody. This is the last question of the review sheet. Chicken on top of 46-meter tall tree tries to fly 17 meters per second horizontally. How long till it hits the ground? Will it clear a 50-meter wide road? And the final velocity of the chicken right as it hits the ground. So we're going to start with a blank slide, but all this information relatively clear. So what we're going to do is to organize our thoughts as usual. Oops, what's going on? As usual, start with our table of horizontal and vertical with time as the bridge. Horizontal, we know that flies horizontally 17 meters per second. So that's going to be a Vx value, 17 meters per second. Vertically, we have our standards. VIY is 0. AY, negative 9.81 meters per second squared. VFY we don't know. DY we don't, DX we don't know. But DY we do. DY is the chicken's on top of a 46-meter tall tree. So looking in terms of what the chicken's going to do, it's going to fall 46 meters. So its dy is really negative 46. All right, so our first question is, how long will it take for the chicken to hit the ground? Well, how long is time, and we have enough vertical information, dy, ay, viy, to find t. So going back to that equation, which is just about almost always used to find the time information, VIT plus 1/2 AY T squared, we can find time. VI is 0, that whole term cancels. So plugging in, just negative 46 equals 1/2, that's a bad A, 1/2 times negative 9.81 times T squared. Multiplying through, I'm just going to kind of skip a couple steps. I don't think the math is an issue for a lot of people. 1/2 of negative 9.81, 4.905. Divide by that, you're going to get a t squared equal to 9.38 seconds, or actually 9.38 squared seconds. Seconds squared. And then when we take the square root of both sides, squareds cancel, and you'll get a time of square root of that number, 3.06 seconds. So 3.06, and if you look at your sheet with the answer, that's the same answer. So that gives you the time. Part A is done. Check that off. Part B. Still using all the same information. We're looking to compare to see if our dx is greater than 50 meters. If it's greater than 50 meters, then the chicken will clear the road. If it's not greater than 50 meters, then the chicken lands in the road and bad things might happen. So we're looking to see if the dx is greater than 50. So to find that, dx, when we're looking at horizontal information, we only use that one equation, dx equals vx times t. Once again, we found t, we know our vx, so it's a very simple part, simple multiplication. 3.06 times 17, 17 times 3.06, 52.02. 0.02 meters. So our chicken went further than the width of the road, meaning that the chicken clears. Yes, the chicken crossed the road. So how did the chicken get to the other side? Projectile motion. All right. I have too much fun with these things. All right, so chicken crossed the road. We have part B in the bag. Done. Last part, part C, find VF. Well, that's a combination again of Vx and VFY. So we have to, just like the first video, have to find VF. Well, similarly, we know Vx is 17 meters per second. VFY we don't know, but we can plug in. We know the time, so our VFY equals 0, which is our VIY, plus negative 9.81 times our time, 3.06. Just using VF equals VI plus AT to get negative 9.81 times 3.06. Could have also done this using the VF squared equals VI squared plus 2AD. Would get you the same result of negative 30.02 meters. So that's this one, 30.02 meters per second. Oops. Meters per second. And that allows me to fill in the triangle. Pythagorean theorem tells me that VF is going to be, I'm not going to know I'm running a little out of space. It's just going to be 30.02 squared plus 17 squared, square root of that. So 30.02 squared plus 17 squared, just the Pythagorean theorem. Take the square root, and I get 34.499, so I can round that to 34.50 meters per second. But just like the first video, that's only the speed. We also have to find the angle. Angle is the inverse tangent. Our angle is always here. Always. That's the nice thing about drawing this triangle. It's always set up the same way, so all the spots are always the same. Inverse tan of opposite, which is my 30.02, over 17. When you plug that in, inverse tan 30.02 over 17, I get 60.48 degrees. Again, that's going to be BH, below horizontal, so my final speed, putting everything together, 34.50 meters per second is my speed, but to make it a velocity, I have to add that direction at 60.48 degrees. Good old BH, below the horizontal. Hopefully, the video isn't blocking that, but again, I'll write it up here just in case. 34, this is our final velocity. Overall, our final answer, 34.50 meters per second at 60.448 degrees below the horizontal. And that is our answer to part C. Looking at it, 34. So mine was 34.52 the initial time I did it. Again, that's all rounding errors, so that's all set. So that's part A, finding the time. Part B, finding the horizontal distance, dx. Part C, finding the overall final velocity, speed, and direction. If you have any questions, please feel free to go back and sort of try and re-listen, and also try it yourself. The easiest thing you can do is just change some of the numbers. Maybe if you want extra practice, try it with a Vx of 14 meters per second and a height of 90 meters. See what happens. It's a great way to try because you'll have a very similar question on your quiz. These are great ones to study off of. All right. Hopefully that helped, and see you in class.